One of the questions we frequently get at AIBL is, what does an IBL class look like? So the topic of this video is to share some commonly used examples of IBL with you. These are examples that are used in classes right now and are practically doable. These examples should not be viewed as the only models or only ways to implement IBL. And the main point of this video is to give you some examples to work off of, to give you something to start with and give you a sense for what an IBL class is like. The first example is Intro to Proofs. Again, I stress that this is an example, not the example. And the key features in this example are student sense making and collaboration. All right, let's take a look at how class starts. So at the beginning of class, the instructor, who's not visible here, goes through and he writes 4 problems on the board, splitting the board into 4 equal pieces, roughly. And then students go up and they write their name underneath the problems, indicating that I can share this problem, I have a proof for this problem. The next step is to select the presenters for each problem. So here you see the instructor has circled specific names of students who are going to present that specific problem. And the way the instructor selects problems based on the rule that the student with the fewest number of presentations up to that point gets to present that problem. So in this case, let's look at Claire here. So Claire had the fewest number of presentations among this list of 3, so she gets to present that problem. Actually, the process is slightly more complex. We see Rogelio has signed up to present 3 problems. Claire has signed up to present 2. If we focus on the third problem over here, we see that Rogelio has already been assigned the second problem, so he could be scratched off this list for the third problem since he already gets a chance in this class period. And then between these 2 students, Claire had the fewest number of presentations, so she gets to present that problem. And then Claire could be deleted off of the 4th problem, and then there's 1 student remaining. So this is a way to spread the work around to different students and make sure that every student has a chance to present problems. Once the presenters are selected, they put up their problems at the same time. So they're all writing at the board at the same time. And the instructor uses this 5 to 8 minute period of time to go and visit other students in the class, the students in the audience who aren't presenting. And that's a good time for the instructor to answer questions, to check in to make sure students are making progress, to see who has solved all the problems, who hasn't solved all the problems, and to get a good sense for where the class is at. After the presenters have written their proofs on the board, then the class goes through each proof one at a time. So in this case, we're at the 3rd proof. We're looking at theorem 2.10, and Claire is presenting her proof. And the way this runs is Claire will run through her proof line by line. Students are allowed to raise their hand and ask questions. And then they have a class discussion about the proof, whether it's correct, whether there are things that need to be updated, and so on. In this example, the instructor is right here. He's at the back of the room and intentionally not at the front of the class. So in this way, the instructor has taken himself off of the center of attention in the front, and the students are at the front, the math is at the front, and the instructor is in the back left corner of the room. And his role is to facilitate the discussion, to make sure questions are being asked, questions are being answered, students have enough time to think and then to respond. One really useful option for instructors is to use something like think, pair, share, or small groups after each presentation. In this case, the instructor can ask each group to discuss with a partner or a group the proof that was just presented and to come up with comments or questions that will be useful for the rest of the class and the presenter. After the presentations and discussions, the instructor's role is to highlight the main ideas and strategies used. He can recap a particular definition that was used, or a strategy, or a proof technique in this case. The part of class right after a set of proofs have gone is a very important time because you have all this wonderful mathematics up on the board, and the instructor can point to these things and offer additional insights, structures, ideas, or strategies that were being used to help students make sense of what's going on. So this is an important coaching and mentoring and teaching period of time. So students have gone up to the board, they presented, they've had a good discussion, and so you want to somehow help students crystallize in their minds how all this fits together. What are they using to help them succeed at these proofs? And what do they need to keep or maintain or refine so that they can make progress on the next set of problems? In this specific class period, there was about 15 or 20 minutes left in the 50-minute class. And so instead of having more students present proofs, the instructor made the choice to have students break up into a couple of groups, so left side of the board and right side of the board, and they worked on two specific problems that were coming up. And the instructor's idea here is, okay, we had some really good proofs go up. Let's get students up out of their seats, working together, and applying these ideas to the next two problems. And this will help students get momentum, ask questions, he can see where they're at, and then also prepare the next group of students to present in the next class period. All right, let's recap what we just looked at in this example. So the first thing is students worked on proofs outside of class, and that's an important facet of AIBL. So what you're doing is you're asking students to take a look at some problems and come back clean, finished proofs as much as possible and bring them to class. And then the main activity that happened in this 50-minute class period, it's student presentations of proof. So that's where students are sharing their work, presenting their proofs, getting feedback from the rest of the class, and an opportunity for the class to agree on whether or not a line of reasoning is a legitimate mathematical proof. One of the main reasons why we have student presentations is to support a class discussion and to have further collaboration based on that. So when a student presents a proof, that gives the opportunity for everyone else in the class to discuss that proof and say, oh, okay, that makes sense. Or, oh, I don't understand line 3. Could you explain that again? And it gives the class a chance to evaluate what's going on, to ask questions, to offer suggestions about how to say something or to offer another strategy. So that's a whole class discussion, a whole class collaboration. And the reason why this is valuable is that then you're making public all of these ideas so that all students have access to these ideas. Presentations don't take the entire amount of time for each class period. And so the next piece is group work. Group work is important because if you're in the middle of a chapter or a unit of problems, then it's natural to say, okay, we proved, say, problems 1 through 4 today. I'd like for you to start working on the next 4 problems so that we can give you some momentum for the next class period. And so group work to discuss the next chunk of work, or it could be to look back and say, okay, let's make sure we fully understand the strategy that was just presented by Rogelio or Claire. Another thing I want to highlight is the fact that students are being mathematicians in this kind of class setup. So in AIBL classes, students get to do the mathematical work and be creative and solve problems and then share them with their classmates. And that's exactly the kind of thing that mathematicians do. Let's talk about the instructor. So the instructor has quite a few roles in an AIBL class, quite a bit more than in a conventional math class. So in addition to presenting ideas through mini lectures, the instructor also has to come up with the problems or the tasks and order them in a specific way so that the class achieves the learning goals of the course. The instructor in an AIBL class also has to manage the discussion. So when you have students presenting, then someone has to manage this discussion and make sure that questions are being answered, that there's enough time for students to mull a proof and to think about it, and also to make sure that students who tend to be quiet are engaged in the discussion. And this requires this idea of real-time adjustments. So there are times when, let's say you write 4 problems on the board and students have only been able to solve 3 of them, then that class is going to progress differently than if all 4 problems the students are able to solve and the proofs are nice. So these real-time adjustments based on what the students come with are very important. So the instructor has a plan for a specific day but has to make real-time adjustments, because it could be the case that students are stuck on a specific problem. And they're like, hey, we need help with number 4. We didn't quite get it. And that may not be something that the instructor planned, but that's something that the instructor should be open and flexible to addressing in real time.